Okay, so what I've been asked to do here is that I've been asked to find the Tn, the nth term of the following sequence. And the Tn, or the nth term, is another way for saying finding the general rule. So what I'm going to do first of all is I'm going to write down the sequence. So it's 13, 17, 29, and 49. So my first term there is 13, my second term is 17, my third is 29, and my fourth is 49. So after that, I'm now going to do the next part, which is I'm going to find the common difference between them. So between 13 and 17, the answer is, the common difference between both of those is 4. Between 17 and 29, the common difference between both of those is 12. And then between 29 and 49, the common difference between both of those is 20. And by common difference, I just mean if you subtract one from the other. So step 1 here is always to find the second difference. I can see it's definitely not a linear sequence because the first difference isn't the same. But if I examine the second difference, between 4 and 12, the difference is plus 8. And the difference between 12 and 20, again, it's plus 8. So I've found that this is a quadratic sequence. Once I've found that, I can say that the second difference is equal to 8. So I'm going to say that the second difference is 2a is equal to 8. And what you need to do now is you need to find the value of 2a, which means you need to essentially find the value of a, and it's going to be divide both sides by 2, and you will get a equals 4. And that's going to help us along the way of finding the general rule for this quadratic sequence. The second thing to know is that a quadratic sequence always follows this pattern here, where the nth term is equal to an squared plus bn plus c. And you will need to know this to be able to solve this question. From what I already know, from solving the second difference, I now know that a is equal to 4. And that's going to play a part right here. But we still have a lot of other unknowns that we don't know. We don't know a b and we don't know a c. So when we have two things we don't know, we always try and form simultaneous equations. So I'm going to show you first of all how we're going to get the first simultaneous equation. Is I'm going to say, right, well, I know that if I look back at my terms and at my sequence up here now, you can see that I'll just move down this, the first term was 13. So if I said to myself, okay, well, if term 1 equals 13, that would essentially mean that this equation here would be equal to 13. So now knowing that a is equal to 4, I'm going to write that down as that would be 4 term 1 to be squared plus b times term 1 plus c would give me 13. If I do a little bit of working out there, I'm going to get 1 squared is 1 times 4, which is going to give me 4 plus b plus c equals 13. And then I'm going to do a little bit of tidying up. Minus 4 minus 4. So I do get b plus c equals 13 minus 4, which is 9. So that's my first simultaneous equation there. I'm going to do it again. Going to remember that, yes, a is equal to 4. I've already solved that. And this time I know that term 2 is equal to 17. So that would mean that it would be 4 times 2 to be squared plus b times 2 plus c equals 17. And to solve accordingly, 2 squared is 4 and 4 fours are 16 plus 2b plus c equals 17. And we will do the minus 16 here and minus 16 here, and that will cancel. And as a result, I'll be left with 2b plus c equals 1. And that there is my second simultaneous equation. I could also have used T3 is equal to 29 and T4 is equal to 49. But for me, the start one, T1 equals 13. So then you input 1 and let it equal to 13. And the second one, T2 equals 17. Input 2 and let it equal 17. That will give me my two simultaneous equations. Okay, so here I have my two simultaneous equations. I'm going to solve them as I would any normal simultaneous equation, which means I want to get my b's to cancel or I want to get my c's to cancel. The easiest thing probably here is to get the c's to cancel, so I just need one of them to be a plus and one of them to be a minus. So what I'm going to do is I'm going to multiply this top line here by -1. If I do that, remember you must multiply everything by -1. So I will get minus b minus c equals -9. My bottom line I've kept the same, which is 2b plus c equals 1. And I can now cancel out my plus c and my minus c. And I'm left with 2b minus b, which is 2b minus 1b, is just b, is equal to, and -9 plus 1 is -8. Once I've solved for 1, I just simply substitute it into either line. So sub in, and I'm going to sub it into the top line, which is b plus c equals 9. I now know that b is -8, so it's going to be -8 plus c equals 9, and I'm going to plus 8 and plus 8, and I'm going to get c equals 17. Okay, so we're not done yet because I was asked to find the general rule. So remember earlier on I said to you there's a really important formula that you need to know when it comes to, if you've figured out that the sequence is quadratic and you've got to find the rule, you need to remember this. So the rule for a quadratic sequence is an squared plus bn plus c, where a stands for the common difference. I've now used my simultaneous equations to solve what b is and what c is. So going back to the very first part, I found that my a was equal to 4, so it's now going to be 4n squared minus 8n plus 17. And that is my general rule for a quadratic sequence or pattern. Okay, so the learning check then. Find the Tn, the general term or the nth term or the general rule for each of the following quadratic sequences. So they've been very nice to you and they've already told you it's quadratic. So follow the simple rules that we've gone through and hopefully you'll get the general terms.